How do you solve the equation?
Once you subtract the one from each side and that's square root.
Yeah. So we would subtract the 1 to the other side. Ooh, there it goes. Wow. All right. Yeah. Okay, so he said subtract the 1 to the other side, take the square root, and the square root of negative 1 is I. That's how we get our imaginary number. Because in math, we don't like when things don't work. We force them to work, creating new things. So you have the real numbers and the imaginary numbers. So the square root of 1 is the value of I. The negative comes out and makes the I part. And then really, you're still taking the square root of positive 1. So whenever there's a negative underneath, you pull that negative out first, creating the imaginary number, and then you take the square root of the real number that's left. So Carrie, the square root of 1 is
1.
But also, right. So the solution to x plus 1 is really plus or minus 1i, or you could just say plus or minus I. You can choose to write your I however you like. I put a little tail in it so that it doesn't look like a number that's kind of scripted, but feel free to write yours however you choose to write it. So I placed a little tail to make it a little scripted because it is a special number. So the imaginary number I is the square root of negative 1. And before we move on, just talking about a couple of powers of I. First 4 powers of I are important powers. So if you have I to the first, that's just I. Because anything to the first is just the value itself. What is I squared? Carrie. Negative 1. And that's because you are taking I times I, which really means you're taking the square root of negative 1 times the square root of negative 1. And if I have the square root of negative 1 times the square root of negative 1, that is the number negative 1. So I to the first is just I, but I squared becomes negative 1. So if I use those two, what would I cubed be? So think, if I to the first is I squared is negative 1, colon I cubed, not positive 1. Carrie? It's negative I. Because the way I get 3 is by taking I to the first and I to the second. So if I take I to the first with I to the second, I have an I times a negative 1. So I get a negative I. So Colin, back to you. I to the fourth is positive 1. And that's because I squared times I squared is negative 1 times negative 1. So those are the first 4 powers of I reduced. And then everything after that kind of follows the pattern that you can use any of the 4 powers to create another power of I. So you will be asked to make sure that powers are reduced completely. We wouldn't leave something as I to the 4th if we can reduce that value. So the first little term here, definition, is the standard form of a complex number. All numbers have standard form. All equations have standard form. All functions have standard form. There's a special way to write things. So when we write radicals, we always write the number and then the radical, whatever it happens to be. Because the integer is more important. So when we write complex numbers, a complex number is a real number, which is the first thing, plus the imaginary number. That makes a complex number. So a complex number isn't just an imaginary number, it's both of them combined together. The real number always goes first. The imaginary number always goes second. Yes, you will lose points if you don't write it that way. A lot of you lost points on your test because you forgot f of x. You forgot x equals. So notation is so important, and if you don't get it this year, like you're gonna lose a ton of points in calc. Calc is all about notation. It's all about answering the question correctly. So if I enforce it this year, then next year you should lose some silly points. And the most you could lose this time is just 1 point. So I took off like a blanket. But I'll start taking off every time that you don't have proper notation. So if it says standard form, the real and then the imaginary. The first one wants you to find A and B. So in parentheses, we have this quantity A plus B. And then we have plus BI equals on the other side 13 minus 4I. And we're just supposed to find the variables A and B. Don't make it overly complex. How would you find A and B? What's the real part on the left? So what part is real on the left side? Colin?
A plus 2.
Yeah, this is the real part, A plus 2. Colin, what part is real on the right?
15.
13. So to solve for A, which is the real part, you set it equal to the real number on the other side. So Colin, A is 11. To solve for B, which is attached to the imaginary part, you set it equal to the imaginary piece on the other side. So B is negative 4. Again, don't make it overly complicated. So the real has to equal the real. Equals means equality, but the numbers can't be mixed together. So if you have a real number on the left, it has to be equal to the real number on the right. The imaginary number must equal the imaginary number. They do not mix. I cannot really combine them together. They're not like terms. They're not like numbers. So the next handful of problems, we're just going to practice simplifying. Some of them are adding and subtracting. Others of them are multiplying, and we will even do a little bit of dividing. So it says add or subtract. Make sure each answer is in standard form. And then in parentheses, the reason there are parentheses is to show you that you have really two complex numbers that you're adding together. So this is a complex number, we're adding it with another complex number. They're just grouping symbols to kind of group two different complex numbers together. So 3 minus I plus the complex number 2 plus 3I. Brenton, what would that become if you're adding them together? Add the like pieces together. Pretend that's X.
It would be 5
Mm-hmm.
and 2i.
Yeah. So imaginary number is just like a variable. So you can treat it as a variable. It has all the properties of X. You add your like terms. So adding the real and then combining the imaginary. Again, they can't really mix together with adding or subtracting, just like I can't add an X and a number. So they have the same properties of X. Letter B, 3 plus 2i minus the quantity 6 plus 13i. So Hannah, what would you have to do there?
I subtracted
6 from 3. So taking that minus sign and 3 minus 6 is
negative 3.
-3. And then
And then I took the negative 9 and then just subtract 13.
yeah. And 2i minus 13i is
Negative 11.
-11i. So again, both of those are being subtracted. Make sure that you're subtracting both of them. So the negative goes to the 6 and the 13 because the whole quantity is in parentheses. Letter C here, we have 3, which is our real number, minus a complex number plus a different complex number. So if we're subtracting, be careful because now this is adding the 2 and subtracting the 3i. So Carrie, if we combine all of our real numbers together, you get 0, and the imaginary numbers,
-2i.
right. Do you have to write the 0? No. So that would just be -2i. So the real numbers cancel each other out, and you're just left with -2i. Any questions with adding? So you're adding kind kind of like their x. Think of like terms. There are 5 examples at the bottom of your page that want you to multiply. Again, each solution should be placed in standard form. When you're multiplying, it's the same as x. So we have negative 8I times the quantity 9 plus 4I. So Dylan, how do you think you would multiply them?
Just distribute it in
Yeah, distribute it in. What is negative 8I times 9?
-72 plus, or
Minus you.
-32.
I squared, yeah. If that were negative 8x, I would have negative 72x minus 32x squared. So an I times an I makes an I squared. Can you do anything further to simplify this? So negative 72I minus 32I squared. Colin?
Couldn't you, since I squared is equal to -1, wouldn't you just multiply -32 by -1?
Yeah. So I squared is actually the value -1. It can be simplified. We can change that number. And then making sure you're writing it in standard form, this becomes a positive 32 in front minus 72I. So the negative 32I squared is really positive 32 and then minus 72I. So letter B, we have a binomial times a binomial. Garrett, how do you think you would multiply that?
I'm going to distribute like 4.
Yeah, FOIL. So, a little bit of foiling here. What do you get when you FOIL this, Garrett?
12 minus 22I plus 6I squared.
And he got the 22 by multiplying the 6 and the negative 3, which is negative 18, and then negative 2 and 2, which would be negative 4. So that's negative 22I. Garrett, is there anything else that we can do to simplify this?
Yeah, you can simplify 6I squared to -6.
Yeah, so that becomes negative 6, and then combining your like terms, you end up with
6 minus 22I.
nice. So 6 minus 22I. No, you don't have to like pull anything out and factor it. Just working on writing it in standard form and simplifying. And then letter C, one more like this because the bottom two change a little bit. We have 3 plus 2I, and then the quantity is squared. So Emma H, what does that mean if we have a quantity squared? Yeah, so you're multiplying it by that same quantity. And when you multiply that, what does it become?
9 plus 12I plus 4 squared.
Good. So again, 3 times 2I, 2I times 3. So that's 6 and 6 gives us 12I. And then Emma, if we simplify it by changing this to -4, you end up with 5 plus 12. Any questions with those three? The two problems at the bottom are slightly different because there are no imaginary numbers in them currently as they're written. We have the square root of -5, and the square root of -10. What do you think you have to do first? Dylan, was that you whispering, or was it Colin whispering?
It was Colin.
Colin whispering. Colin, what do you think?
Pull up the imaginary.
Pull out the imaginary number. So I can't just multiply those and make it a square root of 50. So in order to multiply them, we have to pull out the imaginary number. So really we have I with the square root of 5 times another I and the square root of 10. If two radicals are being written next to each other, we're really multiplying those together. But we cannot multiply until you pull out the imaginary number. And then you're multiplying the pieces that are the same. So the outside parts get multiplied together, which gives us I squared. The inside numbers get multiplied together, which is 50. So outside numbers, when you're looking at radicals, inside numbers, again, like pieces, they have to kind of correspond together. So, Carrie, is there anything else we can do with I squared times the square root of 50?
You can change the I squared to -1.
Right, so this guy becomes a negative. What about the square root of 50?
You can change it to 5 times the square root of 2.
Because it's really the square root of 25 times 2. So he said 5 and then the square root of 2. It's a negative 5 because of the I squared. So the last one on this page, really this is 3 plus I and then the square root of 5. 7 minus I and the square root of 10. So when we write the I, place the 3 first, the I, and then the radical. So you're taking 3 times negative I, and then the square root of 10. So that's negative 3I square root of 10. With the inner term, we have a positive 7 times the I, because that I is outside, and then we have the radical of the square root of 5. And then the last two terms are what we just multiplied together, negative I squared and the square root of 50. So what does the last term turn into? Negative I squared square root of 50. Colin, what's that turn into? Yeah, so that really is plus the square root of 50. And Colin, we know the square root of 50 is really? Square root of 50 is?
25. Square root of 25.
Right, square root of 25 times the square root of 2,
Yeah.
which makes 5 square roots of 2. So that is a real number. It doesn't stay in the back. It goes to the front. So we have the 21. That's the most important number because it's an integer. And then we have the 5 square root of 2. It's still important because it's still a real number. And then there are two other parts that are remaining, and both of them have an I. Can you add those two numbers together? Emma, why not? Exactly, they're different radicals. So even though they're both I, they don't have the same radicals. So we would just write them behind. So now I have standard form. This is my complex number. So there's my real, and back here would be the imaginary. So the real numbers need to be first, the imaginary numbers get it first. Questions with multiplying complex numbers? Yeah.
Doesn't matter which order you put the real numbers
It's-
in.
The real number, like the integer needs to be first. So integer is always the most important number, whether it's positive or negative. And then the square root, and then any imaginary numbers. Other questions? So at the top of the next page, it talks about something called a complex conjugate. And we will use conjugates throughout the entire year. You actually already know what a conjugate is, just may not have seen the word. If you have x squared minus 4, how would you factor that? Colin? Those are conjugates. Conjugates are the same factor, but opposite signs. So those are called conjugates. Anytime you factor and one is plus, the other is minus, those are conjugates. They always occur together because you're solving for something that's squared. So this says that a plus bi and a minus bi are called complex conjugates. So I have a real number plus an imaginary, and a real number minus the same imaginary. It also says their product, meaning when we multiply them together, is always a real number. These guys will always be together because I'm solving for something that's squared. So if I'm solving for something that's squared, I need to have two of them every single time. So the first two examples here, just want you to kind of see how they really do multiply and form a real number. So multiply 3 plus 2i by its conjugate. So if I already have 3 plus 2i, Josh, the conjugate would be 3 minus 2i. And our goal is to multiply this to see, does it really make a real number? So, Josh, 3 times 3 is 9. 3 times negative 2i.
Negative 6i
2i times 3.
plus 6i.
And then 2i times negative 2i.
Negative 2i.
There you go, negative 4i squared. So when you FOIL that, Josh, what do you notice about the middle two numbers? They cancel, and that's what happens with conjugates. Anytime you use a conjugate, the middle two numbers cancel because one's a plus and one's a minus. That works for any conjugate. So if I multiply x plus 2 times x minus 2, that's how I get x squared minus 4 because the middle numbers cancel. If we simplify this a little further, what happens to negative 4i squared? You know, Josh? It becomes a real number of positive 4. So this becomes positive 4 plus the 9 gives us the real number of 13. So the imaginary number, because we're multiplying two of them together, I squared is negative 1. And that I goes away. So looking at the next one, it says multiply negative 4 plus I square root of 2. The conjugate part is in the middle of the real and the imaginary. So it's still a negative 4, and then minus I with the square root of 2. So Lauren, if we multiply this one, negative 4 times negative 4, 16. Negative 4 times negative I square root of 2. Good. And then I square root of 2 times negative 4. And then what happens when you take I square root of 2 times negative I square root of 2? Awesome. So you get negative I squared and the square root of 4. So we know that our middle terms are going to cancel. Lauren, what is the square root of negative I squared times the square root of 4? That's really 2. The square root of 4 is 2. Negative I squared becomes positive 1. So my answer, if I add the reals together, is 18.
Maybe kind of a dumb question, but why would you do plus or minus to be the answer?
Because the only time you're putting plus or minus in there is when you're solving for x squared. Otherwise, it's just the square root of the number as it's currently written. Not a dumb question at all. A very common thing to think about. So the only time you place a plus or minus is when you're solving for x squared. That's the only time it has the two sides to it because it's a parabola. Other questions? So besides the last problem, the next group wants you to divide. And I'm trying to think, I don't think we did dividing last year. Have to look. I think we did multiplication. I think we did adding and subtracting, but I'm fairly certain we did divide i's. I have to look at my notes to see. So this says divide the following complex number. No, we're not using synthetic division. No, we're not using long division. So phew, because there's not x's, so we don't have to use that. How do you think you would divide? If You're not using long division or synthetic division. So the word divide is a very ambiguous word. What's ambiguous?
A big word.
A big word that I like to say.
I don't know what it means. Big.
Ambiguous.
It means that you use both hands.
That's ambidextrous. Still has the same suffix or prefix. So it means both. So divide means there's a couple of different ways to think about dividing. So dividing means breaking down. Dividing means factoring, really, when we're talking about polynomials. Dividing with complex numbers means you got to get the I out of the denominator. So a complex number, when it's in fraction form, you cannot have i's in the denominator. Just like you can't have radicals in the denominator. And once we get to trig, you'll see there's trig things that we can't have in the denominator. How do you think you would get the I out of the denominator, Dylan? I thought you were raising your hand.
Multiply by I over 1.
Multiply by I over 1. You're close.
Multiply by
Emma? Not quite the reciprocal. Here.
Multiply the top and bottom by I.
You're so close.
1 plus I.
negative.
Not 1 plus I.
1 minus I.
1 minus I.
Oh,
So our goal,
See, that is why we went over conjugates.
By the conjugate.
that's why we went over conjugates.
Oh my
Wow.
god.
That's why they're right above.
Oh my gosh.
So we cannot have an I in the denominator. The only way that we can get this to be a real number is to multiply by the conjugate, because that takes the I out of the problem, or out of the denominator. It's still in the problem, it's just out of the denominator. So again, the word divide is not truly what you think of when you think of divide. So our goal is really to simplify this. We're simplifying it by taking the I out of the denominator and using conjugates. So, Carrie, we know the inside terms are going to cancel. So 1 and 1 make 1. And then my last terms, I times negative I, negative I squared. I'm going to skip writing those inside terms because they cancel every time. So really it's the first term times the last term. The top is 1 times 1 minus I, so that's going to stay as 1 minus I. Carrie, what does the denominator become if I have 1 minus I squared?
2.
Yeah, there's my real number, which is why we use conjugates. Now, the question says, write the answers in standard form. This is not standard form, because I have a real and an imaginary number combined together in the same fraction. So it's not standard form. They need to be separated. So if I write this, I have 1 divided by 2. We have a minus sign, and then we have I divided by 2. When you have a fraction, anything on the top is divided by that number on the bottom. So separating a fraction into 2 separate parts is the same thing as writing it together as 1. So now it's separated, my real number and the imaginary number. You could also write this as 1/2 minus 1/2 I, if you'd rather write it like that. But they need to be separate. So the real piece needs to be separate from the imaginary piece. That's standard form. So don't just keep it as one fraction glued together. So looking at letter B, multiply by the conjugate, which means adding 4 plus 2i, or multiplying by 4 plus 2i. Be really careful here with the top and the bottom. There's lots of multiplying i's. Just be careful when you're foiling the top. The bottom, we know the middle terms cancel, so it's multiplying the first and the last terms. We're going to skip letter C. I FOIL the top 8 plus 4i plus 12i plus 6i squared. Brenton, what does the numerator become?
Two
Mhm.
plus 16.
And the denominator becomes
It becomes 20.
nice, 20. So when you simplify this, remember this is not standard form. We have 2 divided by 20, which becomes 110. And then we have 16i divided by 20. What's that? So he said
So it's
4i over 5. So reduce those. 16 20ths is 4/5. So 2 20ths is 1/10. 16 20ths is 4/5. And then this is standard form. Questions? So there is one more fairly involved problem, and that's the one that wants you to perform the operation, which is addition, and then it says write the answer in standard form. So we have 2 fractions that we're adding, complex numbers in the denominator. What do you think you do first?
Oh crap. Did we just skip
Multiply with the conjugate, yes, we skipped letter C, sorry. So we're going to multiply with the conjugate. You want to get the I out of the problem first. So I needs to be eliminated from the denominator by multiplying with the conjugate. So the left side has 2 plus I, that means the right side is 2 minus I. So we're using the conjugate for both sides of the fraction. Remember, the goal is to get the I out of the denominator. Garrett, what's your denominator become?
3.
Oh, so close.
Oh, 5.
5. So our denominator is now 5. They both have the same denominator. So Emma, what can you do with the numerators if the denominator is the same? Yeah, add like terms. So if you combine like terms, we have i's, so 4i and 5i make 9i. And then the negative 2i squared, Emma, becomes 2. And 2 and 10 give you 12. So 12 fifths, and then 9 fifths with the I. So I'm going to skip over the first 10 powers of I. But if you look at the graph, I think it came out really light. Yours is, yeah, it's there, but it's just really light. If you can draw in an XY axis, I think it's there, but it's extremely light. Or maybe it's not there at all. No, not there at all.
Just use your imagination.
We are working with imaginary numbers.
There you go. So we're going to place a couple little tick marks, making our own little graph. when you graph complex numbers, your x-axis becomes the real, the y-axis becomes the imaginary. So you're going to graph it kind of like the x-y ordered pair. So you go over left to right with our real. So here's our real, there's our imaginary. So you go over 2 and then up 3 and place a point. And that would be point A. So the x is the real, how far you go left or right. The y is the imaginary, how far you move up or down. Homework again, not due until Thursday. Anybody interested in doing 37 or 59? 37? Have a good day. See you Thursday.